Okay, sampling bias is some sort of flaw in the design of the study so that one group of people is more or less likely to be selected than another group of people. Sampling bias is often caused by the researchers. The researchers are trying to conduct a study. They say, we're going to go ask all the people that are hanging out near Walmart, and those people are, you tend to get more of maybe one type of people than another type of people in the town that you're trying to study. Okay, so that would be sampling bias. Something that's an error caused by the researchers that increases or decreases the chances of one group of people being selected over another. Sampling error is natural. It's something that the researchers, it's not really their fault. Sampling error is just the natural error that happens because we don't have the whole population. Like if for some reason we wanted to know America's blood pressure, we'd have no bias, we'd have no error if we checked everyone's blood pressure. Right, but that's not practical. So we take a sample, and the sample is just naturally not going to be perfect. It's not going to represent America's blood pressure. So that would be sampling error, just that natural error that comes from not sampling everyone in the population. So we got over here on the left, true or false. So sampling bias is the natural variation that results. So it's tough because it's the first time we're seeing those words, but bias is not the natural variation. Bias is the variation that happens from the researchers having some sort of flaw in their design. Not natural. The researchers are causing the bias to happen. Non-sampling error is the natural variation. Nope, that sounds like sampling error. So which of the following scenarios contains bias samples? That means samples where one group of people is more likely to be selected than another group. It changes, now everyone has the same chance. To estimate the mean number of classes that students take at his university, Benjamin collects data from a randomly selected proportionate number of students from each grade level. So it looks like Benjamin used stratified sampling, collects data from a randomly selected proportionate number of students from each grade level. That sounds good. It doesn't sound biased. All grade levels are being represented. Okay, so let's check the next one. Howard wants to estimate the mean weight of people in his town. He collects data by interviewing members of a fitness club. That's going to be biased, right? Because you're not getting everyone else in the town. The design of the survey is causing one group to be more likely selected than the other group. To estimate the political party distribution of residents in his state, Sean collects data from a large group of randomly selected residents of his city. Political party distribution, residents in his state. Sean collects data from a large group. So Sean's got a large group of randomly selected residents of his city, but that's just his city, right? His city might be, closely aligned with Party A. That doesn't necessarily reflect the state, so that introduces a sampling bias there too. You can't just collect data from your city and expect it to apply to the entire state. If you want to learn something about the state, you've got to sample everyone from the state, or else you have a sampling bias towards whatever political affiliation of that city is. Teresa wants to estimate the mean amount of money spent on clothes per week by mall shoppers. Data on every 10th person entering a clothing store at the mall. It's one particular clothing store, right? If Teresa wanted to make this unbiased, Teresa should check in with every clothing store. Okay, because maybe people that go to clothing store A tend to spend more money than people that go to clothing store B. So some things to think about when statistics are misleading are, what if there's an outlier? The mean is going to be a little bit misleading for the center of the data set because the mean is always pulled in the direction of that outlier. Obviously, a calculation error would make things misleading. If you collect your data in some sort of biased way, whatever results you have are going to be misleading too. So let's take a look here. Ariana collected data from a random sample of 600 people in her city, asking whether or not they bike to work. Based on the results, she reported that 44% of the people in her state bike to work. So it's biased because Ariana is only collecting information on people in their city. maybe their city just has lots of like bike lanes and it's good for biking. That doesn't reflect the entire state, right? So we should say that the sample Ariana is using is biased. Okay, and again, this is because Ariana just got it from one city. You've got to ask everybody in the state if you want to have a result about the state. A shoe company advertises that their average product price is $73, and then they given that their product price is $13, $82, $94, and $103, why is this statistic misleading? I'm looking at the data that they have: $82, $94, $103. The mean might be 73, but it's only that low because of this outlier. If you remove that outlier, the mean is probably going to be something around $90. So, why is this statistic misleading? It's not a big sample size, so that one's kind of tricky. But they do have, it's sufficient because this is all their products, given that their product prices are these four numbers. So we're not going to select sample size is insufficient because we've got the entire population that we're studying. The sample is biased. We don't have any information to think it's biased because it looks like we got the population. The data does contain an outlier of $13. So that pulls the mean away. So it's not fair to report the mean if you have an outlier, because people think, oh, if the mean is this, that means most of the values are around the mean. But if you have an outlier, you have to add that outlier to everything else. It pulls the mean down. One more here. Kenneth collected data from a random sample of 800 voters in his city. Based on the results, he reports in this state. So this is the same one. That's bias, right? You can't just expect the results of your city to apply to the state. Tina collected data from a random sample of 600 students in her university, asking whether or not they exercise more than 30 minutes per day. So this is the same type of thing. Collected data in their university, tried to apply those results to the nation. So that's a biased way of collecting the sample. If you want to talk about the nation, you have to collect a sample that represents the nation.